Hello, my name is Arnar Bjarni Arnarsson. Welcome to Effective Programming and Problem Solving. Now, if you have any questions at any time, just stop me. It's okay if you're interrupting me. Or you can ask a question in the text channel. So, the goal of this course is that, well, we want to be able to solve problems and program a solution to them. So, the steps we take usually are first we do the problem solving on paper. So given the problem, we want to solve it efficiently. And to do this, we apply algorithms that we know and data structures that we know. So we have to introduce the algorithms data structures to ourselves. We then convert our solution into a program. So that's taking our idea and just programming it. Now we have to do this as quickly as possible. We don't want to spend... sound is kind of choppy, cuts a lot. Can anyone else confirm?
Ég heyri ágætlega í þér.
Okay. Recording should be fine. Now, yes, we want to do it as quickly as possible under time pressure. So this is a competitive programming course. In programming competitions, you are limited by a short time. Usually it's 2 hours or 5 hours. And of course, your program has to be bug-free, because if you have bugs, you get incorrect results. And this is the whole process that we will be exercising in the course. So how do we get better at problem solving? First of all, we can study common types of problems. Often in computer science, you will see patterns which help you identify how to solve a problem. For example, we will learn about dynamic programming, and for most of the easy dynamic programming problems, you only really have to know two things. You have to identify two things. We will cover that later in the course. Then, of course, you have learned some algorithms and data structures from previous courses, and we will show common applications of those. We will also introduce you to some other common algorithms and data structures, and then go over some commonly used theory for problem solving. And the rest is just practice. It's just doing it over and over again. Practice makes perfect. There's an unofficial course book. You don't have to read it, but it can be very useful, and I do recommend it. It's known as Competitive Programming. It's by Stephen Hallam. The first edition is free on the homepage. You can also buy a second, a third, and I think the fourth edition is out, but I'm not sure. But I don't think you can order the second version as a book. I think it's only available as an ebook. Now, whichever version you get, if you choose to get one, it should be completely compatible with the course. You just have to search the topic in the book. There is a Piazza for the course. You can ask questions there. I do recommend it if you have something that's not a short question. Otherwise, you can also use the Discord channel here, or you can just send me an email or a direct message. Anything is fine. That was not what I intended to do. Now, the schedule. There are 15 classes in total, but the fifth one will be a day off because of the 1st of May. And that is kind of unlucky. It's on a Friday, so the Thursday this week is a Friday for categorizing purposes. So you can see the problem session is this Thursday. It was supposed to be on Friday. And then we have the optional problem sets also on Fridays. So it's strings and geometry. These are the two problem sets that will not be on the final exam. First, I'm just gonna do the introduction. We'll cover what's known as ad hoc problems. Then we'll move on to data structures. After that, we'll go to problem-solving paradigms, greedy algorithms, dynamic programming, and later on we'll be working with graphs. So each Sunday is a due date for the problems. So the problems sets in week 1 are due on the first Sunday. And then week 2 is due on the second Sunday. And then week 3 and all the bonus problems are due on the last Sunday, 17th of May. Now, so each class in this course covers a different topic, as you can see on the schedule. There will be a talk about the topic before noon, and then after noon we'll be working on the problems. So I want you to group up by yourself, and if you don't have a group, then I'll help you find one, because you need to be able to discuss the problems. Sometimes that's all you need to reach the solution, is to have someone to talk to. And I'm sure all of you know the rubber ducky method, where you just talk to a rubber duck. Even that is very helpful. You just need to, talk about your idea. If you keep it in your mind, then you usually don't notice the same things you would. Now, even if you're working in groups, you need to make your own solution in code. So you need to write up the solution. You can work together to solve the problem on paper, but then you write up the code yourself. And Catis has a built-in plagiarism system, so if submissions are similar, it's very easy for me to see. Now, the problem sets usually are around 5 problems, and each problem has some amount of points. And then I will also tell you how many points you need to get a perfect score. And this is just linear. So if you get the score I ask for, that's a 10. If you only get half of the score, that's a 5. In each set, we have 2 bonus problems. They are usually much more challenging, and they are only included in the final grade if the student passes the course before the inclusion. So you need to pass the course. This is only to raise your grade. There will be no late hand-ins, and solutions will not be partially graded. So what that means is that Catis will give you your solution a verdict for each problem. If you get accepted, then your solution is correct, and you get points for it. If you, however, get some sort of an error, so that could be a compile error, or a runtime error, or a wrong answer, or you exceeded the time limit, or you exceeded the memory limit, and there are a few others, but you probably won't see them, then the solution is not considered correct. And as long as you have one accepted solution to a problem, you will be considered to have solved the problem. Any more people having sound issues? No? Okay, good. Okay, so the Fridays or Thursday in week 1, we have a programming contest. So we call a problem session. And in the problem sessions, we will cover the topics that we have seen so far. So this Thursday, we will cover the problems in the introduction, the ad hoc problems, and then data structures, and that's it. Yeah. So in these competitions, you will work with your group in a team, and you can be in a team of up to 3 people, but the team can only use a single computer. And since we're all working from home, what that means in your case is only one computer is used for programming at a time. So that's how we will emulate a standard programming competition. Because usually the team just has a single computer. And then there's one person or two people that are, programming or pair programming, and the others are just discussing a solution to the same problem or a different problem. It's just whatever method the group finds effective. The last Friday will not have a programming competition. It will have the final exam, which is very similar to the problem sessions, except that it's not a group effort. You're all alone there. And I do highly recommend that you attend the problem sessions. It's not mandatory, but it's good practice to get you prepared for the final exam, because the time constraints there are, they're more restrictive than in the problem sets themselves. You only have a couple of hours to solve the problems. And finally, you need to pass the exam to pass the course, even though the exam is only 20% of the final grade. Now, there are 12 problem sets in total, and they account for 70% of the grade. Now, there are 2 optional problem sets, the strings and geometry. That's the ones I recommend, since they're not on the exam. But you can do them instead of some others and skip those. It doesn't matter which ones you choose, just the best 10 give 7% each. Then there are the 2 problem sessions, 5% each. They're not mandatory, but the final exam is. The final exam accounts for 20% of the grade, and the bonus problems account for 20% of the grade as well. But remember, they will only count if you pass the course before they're added. And then finally, if you do all the problems, you get 120% of the course complete, you still only get a 10. It's just the system at the university. Okay. Any questions regarding the logistics of the course, the setup?
Sorry, I have to pass the final exam, right? I can't get 100% by doing everything else and pass the course like that, can I?
Yeah, you have to pass the final exam. So you need 4.75 on the final exam. All right. So let's get a bit introduced to competitive programming. So the typical problems consist of a number of parts. First of all, there's the problem statement. This is just a text that describes the problem. There may be images to help convey what the problem is and, explain to the contestant what he needs to do. Then there's a description of the input. So this tells you usually constraints on the values and what type they are. So if it's text or integers, decimal numbers, and then, for example, if the input is just a single integer, it will say the integer is between value A and value B. Then there's an output description, which describes how you should be writing output to answer the problem. Then at the bottom, you can usually see an example of an input and output to demonstrate to you. Just an example of how the problem works. And usually, if you believe that the sample is incorrect, then that means you're misunderstanding the problem. It's a good tip to have in mind. If the sample doesn't make sense, you probably misunderstood the problem. You should read the text again. Finally, there are 2 values that can have a great impact on how you solve the problem. First of all, the time limit. This is usually just in seconds, integer seconds. Like, you don't have a half-second time limit, you have a 1, 2, 3. And then there's a memory limit. For most problems, you don't have to worry about the memory limit at all. It's gonna be a gigabyte, maybe 2. Sometimes, however, memory limit is reduced when they want you to do something clever with, for example, there's a problem where you're asked to find all the prime numbers in some range. So you do what's called a prime sieve, but you have to do it in a way where you don't use too much memory. You only have 64 megabytes to use, and you need to get the first billion numbers. So that can be an extra challenge to the problem. It's conserving the memory. Now, what you have to do is you have to write a program that solves the problem for all the inputs that the input description allows for. And you may not exceed time or memory limits at all. So if there's a 1 second time limit and your solution takes 1 second exactly, then you're good. Or 0.99999 and recurring. It depends on the judge. But if you just exceed that by a nanosecond, then it's a wrong answer. Like, that's time limit exceeded. It's not a correct solution. Usually the correct solution runs well under the time limit. So keep that in mind. If you're struggling with time limits, or maybe if you solve the problem but you're just so barely under the time limit, you're probably not doing the intended solution. So let's look at an example problem. The problem description is simple this time. Usually it's a lot longer. And it just says write a program that multiplies pairs of integers. Then we have the input description. So the input starts with one line which says the integer t, and that's 1 to 100. This denotes the number of test cases. Okay. Then t lines follow, each containing a test case. And each test case consists of two integers, a and b, where a and b are in the range negative 2 to the power of 20 up to positive 2 to the power of 20. They're separated by a single space. Okay. And then for each test case, we're supposed to output one line containing the value of a times b. Okay, seems simple enough. So here we have a sample input and sample output. So there are 4 test cases. The first is multiply 3 and 4. The answer to that is 12. Then 13 times 0 is 0. 1 times 8 is 8. And 100 times 100 is 10,000. So let's look at a possible solution to this. So first we read in the value for t. And then we go through this loop here where we handle each test case separately. So we read in a and b into the int data type, and then output the values multiplied with each other. And then a new line at the end. Okay. So now I ask, is this solution correct? Oh, maybe one thing I should ask first. Is everyone here familiar with C++ in some way? Does everyone use a different programming language?
Það er svolítið síðan að ég gerði eitthvað í það. Ég svona byrjaði að fitta með Python í þessu. Ætti maður nota C++ í þessu eða skiptir það engu máli?
So the question is, should you use C++? The answer is no. You can use any language that Catus supports. You can find that on the Catus help page.
Yeah, I noticed that, but do you recommend C++ or just for the simplicity or whatever?
I recommend C++, and if that doesn't work for you, then I recommend Java or Python. And
okay.
Then you can consider the rest. But if you want to work with JavaScript, whether it's Node.js or just vanilla JavaScript, then that's completely fine for this course. It's just not recommended in general for programming competitions.
Is there any reason in particular you recommend C++, or is it just personal bias?
I'm sure some of it is personal bias, but I have yet to encounter a programming competition where C++ is not a valid option for a programming language. So, for example, the ICPC collegiate competitions, they allow C++, Java, Python, and a few others. I don't remember which ones. I think it's Go and Kotlin. And then the high school competition, international high school competition in informatics, IOI, that one allowed C++, Java, and Pascal, but they just recently removed Pascal and they're considering adding Python. So a part of it is accessibility. You'll never have problems in a programming competition with your language being unavailable if you use C++. The same is true for Java. However, Java has some issues with input and output. Input and output in Java is extremely slow unless you work really hard to get it faster. Whereas in C++, it's it's just the standard I/O is really fast. Another thing about speed is that C++ just generally runs faster compiled than Java and Python, which are both interpreted or partially interpreted. However, I think Go also runs at the same speed compiled as C++ programs. So that's kind of why I recommend it. And C#, same as Java, it's partially interpreted. It has there's a virtual machine behind it. So yeah, that's really the reason why I recommend it. Any more questions? Okay. So let's try to figure out, is this solution correct? Note the data type here, int. Int in C++ means a 32-bit integer. So what happens if A and B are both 2 to the power of 20? What's the answer? Or what should the answer be?
2 to the power 40.
Correct. And can we store 2 to the power of 40 in a 32-bit integer? No. So when we multiply them together in a 32-bit integer, the output is 0. So this is not a correct solution. So what we need to do is use, the next size, 64-bit integers. Now, note that if you were doing this in Python, you wouldn't even notice this, because the default integer in Python just expands as needed. As far as I can remember, there's no data type like that built in C++ in the standard library. So that is, for example, an advantage to knowing, Python or Java in addition, because then you can do problems that require huge integers in those languages. Java has the big integer class, with part of the standard library, and I think most libraries that are being released, standard libraries in programming languages, include some form of this. So let's fix our solution here. We'll change the data type to long. This is a 64-bit integer. Now is the solution correct?
Sure.
Yes, it is. It is correct. Okay, so we would submit this solution on Catis if the problem were there. And Catis is an online judge, so some of you have used Mushak. I think it's still used in the algorithms course. So probably all of you should have used Mushak. And then maybe some of you used Mimir from programming. These are all similar programs. You submit a solution and then you get an immediate feedback about the solution. And like I said before, you can use any language that Kata supports, but I can't really help you that much with programming in Haskell or Kotlin or Rust because I don't know those languages. So what kind of feedback do we get? It's very limited. Accepted is the one you're looking for. This is the only one that counts as correct. Then wrong answer is the one you'll probably be seeing a lot. That just means that your output did not match the expected output. Then we have compiler error. If you get a compiler error on Catis, it will usually show you why. It will point out what's wrong. Then there's a runtime error. You will not get to know what's wrong, except if it's an unhandled exception, then you may get, the type of the exception. So suppose you're writing in Python and you index a dictionary with a key that doesn't exist, then you'll get a key error. So Catus will say runtime error, and then below it will show key error. Then we have time limit exceeded. So that's just, your program was too slow, didn't finish in time. Memory limit exceeded, it used too much memory. Which one of these you get just depends on the order you get them. So Catus will start on test case 1, then do test case 2, then 3, then 4, up to the final test case. The first test case to fail, it will show you the error for that one. So your solution could have a wrong answer, a runtime error, and a time limit exceeded on different test cases. But it will just point out the first one that occurred. Finally, we won't be revealing any test cases to you. So if you're getting errors, then I'm not gonna find the test cases that Catus uses. I don't even have access to them, so I couldn't show you. You just have to think about edge cases and maybe try to prove that your solution is correct. So there are a couple of tips that is good to keep in mind for becoming a better programmer. Some of these are in general, and some of them are very specific to competitive programming, and I don't recommend doing them at an enterprise level. When you're working on some software for a business, you should not do them. So the first one is just type faster. Just don't be limited by the speed of your fingers. And type racing is a fun way to practice this. And you shouldn't have to write a lot of code to solve most simple problems. And that's most competitive programming problems. They are the total code you require if you use a standard library is not many lines. I rarely go over 150 lines for a single problem. The next tip is just to type less. So a lot of the subtasks you have to solve or do to solve a problem are just things that are implemented in a standard library, or maybe, you know, let's say you have to solve the shortest path problem as a part of the whole problem. Then, as you learned in the algorithms course, there's a well-known algorithm by Edgar Dijkstra which solves this. So you can just, have a library which includes the algorithm, and then you just call that in your problem. You should also I recommend having a template which you start out with. So for each problem, you just use that template as your starting code, which imports all the things you need. And I will show you an example of this later. And yeah, standard library. Just, know the standard library. So an example of how to type less in C++ is, for example, for loops. This is a lot of code to write for just a for loop. So we can make a shorthand for it by using precompilers. This is a precompiled header which defines wrap IAB, so it searches for this pattern and then replaces it with this. So then we can write this code instead for a for loop. This just does the same thing. And then, speaking of shortest distance, I believe this is the Floyd-Warshall algorithm, which is also shortest path solving algorithm. This is just 3 for loops. So this here is an algorithm which you can write really quickly. It's a really short code if you use this precompiled header. This is something I would say is this is specific to programming competitions. I don't think you should do this when you're doing some business software. It may make the code less readable. Then we have some more tips in C++. So here we have a dynamic array, a vector of integers. And this line is even too long for the slide. There's just a plus here to go to the next item. What we're doing is we're iterating through the list and then outputting each value. So we start at the beginning until we reach the end, and then this is an it plus plus, so it increments here. We can do a shorthand for this. Here we're just escaping the new line. So the precompiled header won't, add that each time it finds this. It won't add a new line to the code. And then with this shorthand, we can just write this iter of it and r. This is much shorter. I think there's a recent version of C++, like 2017 version or 2020 version, which adds something like this to the standard library. But I'm not sure. And then finally, you can do something like this. This works in Java as well for a for each loop. But you can see how it takes so much longer to write this line here than it does to write these. And sometimes this time can matter. Var einhver spurning? Okay. Now, here's an example of a template. So here we have our precompile headers, and then in C++, everything in the standard library is in this namespace std. And then we have this include statement here. This basically includes everything, almost. Not completely everything, but 99% of the entire library that your compiler has access to. It's basically just a shorthand, so you don't have to specifically import Q, specifically import IOStream, and all the different headers that you may be using. It's just to remove that worry that we aren't including what's required. And then we have some type defs. These are really useful as well. So for example, long is something that you'll probably use a lot. 64-bit integers. So instead of writing long, you just type ll. Same with a vector of integers. This is a dynamic array. Just writing vi, so you don't, for example, you don't have to write the less than or greater than symbols. Same with pair of integers. This is really these are data types that you will use all the time. This is also why, for example, in Java and Python, it's good to, well, maybe not in Python, but in Java it's good to write classes for custom data types. It's highly encouraged in Java to always do that instead of using some tuple like this, something that's really general. Java wants things to be like the design principle in Java is that things are specific. So you may think that it slows you down to write the class for the data you have to store, but usually it just speeds everything up because you've added more structure to it and you know what you want. Another thing that's useful to have are constants like these. So infinity, this is just the maximum value of a 32-bit integer. It's useful to have this to, have some sort of error code. So let's say you want to find the minimum value for something, or say it's impossible. Then it being impossible could be symbolized by the minimum value being infinity. So if you start with the value is infinity, and then you try to get, find some value which works, and you can't find any, then the value will still be infinity. And then at the end, where you do an output, you can check, okay, is my value infinity? Then I output impossible, otherwise I output the value. We will probably have a problem like this later on. Another thing that can help is classifying problems. This isn't really effective unless you're doing something like the collegiate programming contests, because there they look for something, specific, like a specific set of problems which cover some topics. So here we have a table which shows for some Asian regional contests the frequency of each category. So we have the ad hoc category, which is either just it's just a straightforward implementation, or you're just supposed to simulate something. And there there's 1 to 2 problems there in straightforward, and then 0 to 1 in simulation. Then we have a complete search problem. It's where you just look through all the possibilities and find one that works. 0 to 1 of those. And this is either done. This is considered either like iterative, so just, for example, trying all pairs of doing something. So if you like look through each pair, and then you can check if the pair is valid. With backtracking, then you're doing something. You're doing recursive, trying all possibilities. It can be something more complicated. Then we have divide and conquer, greedy, dynamic programming. Like, these are all categories, and they will have some standard frequency. And like I mentioned earlier, often, like, if you identify something in a problem, then it can tell you instantly, oh, I can use dynamic programming here. It's a very specific property. And then the category everyone hates, computational geometry. It's a pain to program these, although the problems can often be easy. And then this harder problems, this just means something creative. It's something that's, not standard, not standardized like these. So it's good to be able to just, look at the problem set in, as a whole, and like if you do a programming competition and you've done all the problems except the last one, and you've done no dynamic programming, then it has to be dynamic programming, basically. I can't think of a single programming competition that did not have at least one dynamic programming problem. But it's not something you should get stuck on. It's better to just, look at the problem statement and really think about the problem. Algorithm analysis is also very important. So when you're solving a problem, you want to keep things simple. You don't want to overcomplicate your solution. So when you have an idea, it's really useful to do an algorithmic analysis of it. And a number you should keep in mind is 10 to the power of 8, because that's the operations per second you should be using when analyzing. Although recent experience has shown that 5 times 10 to the power of 8 is closer with modern hardware. But this is something you can just, account for on the fly. Like if your code does 10 to the power of 9 operations, then you just divide by the number of operations per second, and then you will see how many seconds your code will run in, probably. Usually this is a rough estimate which you do. So for example, if you want to sort up to 1 million integers and we have 3 seconds, can we use a quadratic bubble sort? It's not going to work because 10 to the power of 6 to the power of 2 is 10 to the power of 12. If you divide that by 10 to the power of 8, you will get 10,000 seconds. Now it's probably going to take less because bubble sort is a really simple algorithm. It doesn't do a lot of operations, but it still scales quadratically. So you can see just from that it's not going to work to use the bubble sort. But the more complex merge sort, which runs in linear arithmetic time, or O of n log n, that's going to be 10 to the power of 6 times log of 10 to the power of 6. And this is base 2 log, so that's going to be 20. So that's 20 million operations in total. So that's going to run in 0.02 seconds, or maybe even less, maybe more. But it's going to be around that. However, let's say the problem changes. Let's say we only have 1,000 integers at most, and still we have 3 seconds. Can we now use the quadratic bubble sort, or do we still have to use the merge sort? Like how many operations would this take? If you use a bubble sort and you have up to 1,000 integers, it's going to be 10 to the power of 6. So that's going to be 0.01 seconds. So this is going to be a much simpler way to solve the problem, given that the constraints are easier. We don't have as many numbers, so we can use something simpler. And you should always go for the simplest solution that will work. Don't try to make some crazy advanced algorithm just to have the code run 10% faster, 20% faster, 50% faster. Doesn't matter. If you get accepted, that's it. That's all you need. You should also be able to do this in your head, just like mental calculations. And a good thing to remember is that each 10 powers of 2 is approximately 1,000. It's 1,024. So if you have 2 to the power of 30, then that's going to be 10 to the power of 3 to the power of 3. So it's going to be 10 to the power of 9. So just each 10 is going to convert to 10 to the power of 3. And like I mentioned earlier, when you get a wrong answer, or maybe you're just not sure, maybe you haven't submitted and you're just not sure about your solution, try to prove it. You've done proofs in discrete mathematics. Depending on what your algorithm is like, you may prove it with induction or some other method. But at least convince yourself, even if you can't make a formal proof, at least convince yourself with logical steps that your solution should work. And even if even if it doesn't work, even if you convince yourself differently, like that your solution is incorrect, then that's still good. You will understand the problem better. After each failed attempt, you will understand the problem better. You will be able to notice something that you didn't notice before. Now, we can sometimes look at the constraints, and that will help us determine like how complicated our solution can be. So, like in this table, if n is less than or equal to 10, and we have to, maybe look at the order, like how we can order some object, then it's easy to just loop through all the permutations, like all the ways you could order the 10 items you have. You can just do that as long as there's 10 or less. So that would give us an n factorial algorithm. Then you have something which is, exponential. This is the dynamic programming solution to the traveling salesman problem. Then something that's also exponential, but it doesn't have a polynomial like here. So this is exponential, but no polynomial multiplied with it. And that's just, a dynamic programming method which uses something known as a bitmap technique. Then, like we saw earlier, the Floyd-Warshall algorithm, which was just 3 for loops, that's n cubed. You can always see this from the input sizes. Is once you've reached something that's 10 to the power of 6, you need a linear solution, or you need a logarithmic solution, or a constant solution. And this 10 to the power of 6, the reason for that is if your problem is asking for like a list of integers, for example, then in order to be able to read all the integers in, you can't have more than 1 million usually, because as I mentioned earlier about Java, it has really slow input, and C++ and Java are basically like available in every programming competition, so you can't read more than 1 million, or like an order of 1 million characters. 10 million characters is about the maximum in 1 second, I think. And there's basically no way around that in Java. You can do some tricks to speed up, but it's just not gonna be enough. Another thing you need to do is master the programming language which you use. You need to know the programming language like the back of your hand. Or you don't need to, you should strive for it. You want it. And this specifically includes the standard library of your programming language. So if you're using Java, you should know what's available. You should know the class library which you have at your hand, because everything in the standard library is gonna work. The chances of it being bug-free are way higher than your code being bug-free. It's been analyzed by so many people. And also it will save you code. You don't have to write it yourself then. So saves time, and it's more likely to be correct. And then of course testing. You need to test your solution. If you write your code and submit it to Catis right away, then you're just asking to get a wrong answer. I know this was common in other classes, like in the algorithms and programming courses, which were using Mimir and Mushak. People, they didn't test their code locally. They just submit it. You should never get an incorrect answer on the samples. So that's usually the first 2 test cases. You should never get an incorrect answer there. You should test your code locally on the samples, and then maybe you make more test cases, maybe you don't. Depends on how complicated the problem is. Like for most of the problems in problem set 1, you probably don't have to write extra tests. And you need to test edge cases. So these are usually either really small or really large inputs. Like the examples here, n equals 1, n equals 0, -1. And then if you have something like a group of people, you have many people and each of them has some items. Maybe a weird input would be that you have a lot of people, but none of them own any items. So you have basically a list of lists, but each list inside the big list is empty. If that makes any sense. It's just you need to search for what's, stuff that is valid, but it's kind of silly. Doesn't make sense. Don't just test average cases. Usually, your code, if your code runs too slow, it's not in the average case. It's gonna be something like the largest input, an input where the you're separated by some fixed length at each item. You're gonna see examples of this later. It's gonna be very specific, the worst case, and you can do algorithmic analysis to try to discover the worst case. If you just think about how your algorithm works, what would make your algorithm take the most number of steps? And then if you submit and you get the wrong answer, you just need to try to find the counterexample. Just look at your code, think about the steps it takes, what could go wrong. It's a runtime error. This is usually, you're indexing something incorrectly. You're dividing by 0. Like these are common. And finally, practice, practice, practice. There are tons of problems online on different online judges. You have Catis, you have Codeforces. These are my top 2 favorites. You have HackerRank, CodeChef, UVA, and Topcoder. There's one I particularly like as well. It's called @Coder. It's a Japanese website. It has really creative problems in the contests it hosts. It's usually not something as standard. Codeforces has more standard problems, and same with HackerRank and CodeChef. Yeah, I mean there's just endless resources to practice. And even without the online judges, you can search past programming contests like the collegiate programming contests. So, for example, just the Northwest European contest last year, if you just Google the name of the contest and then the year, you will find the problem set in no time. Okay, so the first type of problems we will be looking at are ad hoc problems. These are straightforward or just a simulation. So you usually just get, you usually kind of get the solution in the problem description. So the problem description will perhaps describe an algorithm which you have to program. And there's no real, you don't have to do any problem solving. All you have to do is programming, essentially. The input sizes are usually very generous, so time limit is not an issue. But sometimes the problem statements are really long, and you look at them and you just don't want to read it because it's 2,000 words, and they can be also very misleading. So here, this is the kind of problem which tests your reading comprehension more so than problem-solving skills. And for the complicated problems, the complicated ad hoc problems, they're just hard to program usually. So they either require a lot of code or they can be difficult to simulate. Like this is a simulation which is harder to write code for. So I gave you some warm-up problems. I think all of them would be ad hoc problems, except maybe one of them. And the first problem set should be live now. Maybe someone can check on Catis. Okay, great. And the deadline for that is next Sunday, but please start today. Because if you don't start today, then you'll just be behind schedule. Of course, you get an extra day because of 1st of May. But you need to have done the problems before the problem session on Thursday, at least some of them, so you aren't lost in the problem session when it comes to that topic. And that's it for the lecture today. I wanted to show you or go over a problem here. Yeah, this is a good one. Okay. So this is one of the problems. You can see here the problem statement is quite short. There are pictures to illustrate. But this is an ad hoc problem. This is just gonna describe something really straightforward to you. There's no algorithm which you need to invent to solve it. And then we also have this problem, which is not as nice. And one thing I wanted to point out about ad hoc problems is it's not uncommon for them to have some sort of list or table like this, because it's often just giving you a mapping. So maybe, for example, you could be given a problem which is translate text into LeetSpeak, and then they will show you if you're writing E in LeetSpeak, it's a 3, but if you're writing U, it's 3 different characters together. So it can take a lot of time to set up the problem, and then the code itself is really simple. You're just like using the mapping defined in the statement. Also, you see the here the statement is not that long. I don't think none of the problems in this set have really long and annoying statement. This is sort of the thing you can try to help you identify. If you have something like this, it's likely an ad hoc problem, just something straightforward. If you have like a list or a table describing these things, especially if it's a big table, it's very common that it's an ad hoc problem. All right, any questions at the end?
Sorry, you go ahead.
Yeah, sorry. The first problem sets, these are individuals, and the group exercise is on Thursday, right?
The first problem session, which is the group programming competition, is on Thursday, and the second one is on the next Friday after that. So in week 2, and then the Friday after that, week 3, is the final exam.
Yeah. So we start with individuals exercises now.
Yeah. So you can and you should discuss the problems in a group, but you have to write the code yourself.
Just asking whether the problem sets are group or individual.
The problem sets are, you make the code individually, but you can and you should discuss the problems with your group.
Are groups permanent?
No, they don't have to be permanent. But it's good to work with someone for more than a single day.
I believe you said that we would organize ourselves into groups.
Yes, but those who remain, I want to group them together. I don't want people to be alone, because it will make solving the problems which come later on much harder.
Because of sound issues, I lost quite a lot of the logistics part.
Mm-hmm.
So you'll have similar questions to me, but so the group sizes are like 3 people or something.
Yeah, 3 people at max.
Okay.
So preferably you want to work the problem sets and the problem sessions in the same group, because then you get practice together.
Yeah. It will work like a machine.
Yeah.
Later on. Yeah.
I will be uploading all the lectures on YouTube. So if you miss out on any lectures, then you can watch them later. I will be online here till at least 4 o'clock. So you can get instant feedback from me during that time. However, later in the evening and during weekends, it's better if you ask on Piazza than on Discord, because it's not gonna be instant feedback. So if there are no more questions, then it would be good if you move into groups. There are voice channels for you on the server. It would be nice for me if you use them instead of something else, so I can hop in your chat with ease if you need help from me. But I mean, you don't have to use them. It's just easier for me to assist you that way. So anyone that will be remaining here that doesn't move into a group, I will help group you, get you into groups. Okay, so everyone here is without a group. Okay, so first I want to ask a question. Is there anyone here who will not be able to make it to the problem session or does not intend to? Because I don't want to group people who can't make it to the problem session with people who can, and then they're, you know, out of a member or even solo.
Can you remind me what problem sessions are?
What?
When are problem sessions again? Friday
The
before?
the first one is Thursday this week, and the session is afternoon, so it's 1 o'clock to 4 o'clock.
It's just online, yeah? It's all online.
Yeah, everything is gonna be online.
So
unless the like administration wants me to have the final exam local later on, when the school might open up. But I assume it'll all be online.
yeah, I can make it.
Just let me know if you can't make it, and then I'll put